this assessment asks us to pick out the least acidic proton in the two molecules shown without using pKa values. If we can't use pKa values, we have to use the structural effects on acidity. And so to do this, let's start by drawing the conjugate base of each. The conjugate base of the ammonium ion will be NH2, and we're going to specify the lone pair being on nitrogen because that's going to be important to answering this question. We can draw the phosphine conjugate base, and we see that this conjugate base will have the lone pair on phosphorus. And so if we think about the instability of the amine and the phosphine arising from which would rather have the lone pair on, which atom would rather have the lone pair, nitrogen or phosphorus, we can now compare nitrogen and phosphorus directly. Both are in the same group, with phosphorus being a little bit lower, meaning phosphorus is the larger atom. Phosphorus is larger. A lone pair is more stable when it's on a larger atom. The phosphine is more stable. If the phosphine is more stable, then the acid is going to be more acidic. This proton will be more likely to be given up to make the larger, more stable conjugate base. This question, though, asked which is the least acidic proton. In this case, it's going to be the ammonium. The ammonium is least acidic because its conjugate base is less stable. Why is its conjugate base less stable? Because we have the lone pair of electrons on the smaller nitrogen atom.